Since its mainstream popularization in the early 2000s, 3D printing has become the easiest way for a creator to turn the dream of a product into reality. 3D printing, or additive manufacturing, is the creation of a 3D model from a CAD software. 3D printing has revolutionized the prototypes of objects for one main reason: it's cheap. At the tip of your fingers, you can have something go from an idea to construction in under a day. Prior to this process, you had to hire people to manufacture products using big expensive equipment such as CNC mills and lathes, and not to mention that they were specialized workers. It was a long, intensive process, but now, in your office, in your garage, you have access to all the tools needed to turn a dream into reality. A 3D printer works through a process known as additive manufacturing. Additive manufacturing is taking a part and building it up layer by layer to get your end result, rather than starting with a chunk of material and removing it to get your product. Traditional methods such as CNC mills or routers use the process known as subtractive manufacturing, which is the latter of which I just described. You start with a big chunk of material and then carve out what you need to carve out to get whatever the desired product should be. Now let's break down how the additive manufacturing process works. When a 3D printer prints, all that's changing is the location of the nozzle head. When a part is to be printed, software takes the model and slices the part into layers that tells the printer where to print. The amount of layers depends on the thickness you set, and every layer will always be the same thickness. The lower the thickness you set, the more detail you get, but the more time that the model will take. As all of these layers stack up on top of one another, you start to see the complete part. It's a really cool process to watch a printer start from zero and build a whole part. Kind of mesmerizing if you ask me. Like its own little therapy. We now know how a 3D printer works. Cool, right? But what does that mean for me? How do I get into it, and how do I actually create that little thing that's printing on the bed? You only need three things in order to get started. You need a CAD model, you need a slicing software, and then you need a printer itself. And let me take you into a little bit of detail on each of them. The first requirement is the model. Makes sense, right? If you don't have anything to print, well, you can't print. A model can be gotten from two main ways: designing your own part using a computer-aided design software, or CAD software, or pulling a part off Thingiverse. A CAD software is a 3D software that allows designers to create any kind of part that they want from scratch. These parts can be on any extremes of the spectrum, from parts as simple as vases all the way up to full complex parts such as rockets or cars. If you're interested in getting into CAD software, there's many tutorials out on YouTube. I'm not going to go into any details about the CAD softwares within this video, but the one that I recommend using and I personally use is Fusion 360. There's wonderful YouTube tutorials that I'll link within this video and plenty of resources online to get started, not to mention it's free for hobbyists to use. If you don't want to take the time to learn a CAD software, don't fret. There's this wonderful online website known as Thingiverse. Thingiverse is a website where designers all over the world upload their pre-existing models that they've designed for other people to go and print. The best part is these models are usually pre-printed already, so they have a high success rate and are designed to be used in 3D printing applications. You don't have to know any kind of CAD software. You can just go and download something, upload it to your slicing software, and go off and print it. There's designs that are as complex as 3D printed drones, phone stands, but sometimes even designs that are as simple as just a little figurine to go right on your desk. If you're not looking to learn a CAD software, I highly recommend just scrolling through Thingiverse for fun. The randomness on there is sure to bring anybody joy, and I've even pulled some random objects that I knew I haven't needed and just printed them for fun. I've taken chess pieces, blown them up, and used them as trophies. Scroll through, have fun with it, and it's a wonderful place. So now you have your model. The next step is to tell the 3D printer how to print the model. This is done through a piece of software known as a slicing software. The slicing software takes the model and then breaks it down into layers. Imagine an onion that you slice for hamburger and slice it very thinly across the entire onion. It essentially works in that same type of a process. Once the model breaks down these layers, it then translates those layers into something known as G-code that tells the 3D printer where to print the layers. Now this may sound incredibly complicated and daunting to use, but I assure you it's probably the easiest part of this entire process. The software that I use is Ultimaker Cura, and I highly recommend everybody using this software as well, as it is incredibly straightforward to use. There's a wide variety of presets and printer inclusions that cover almost every spectrum of printer out there. There are only four main buttons or settings that you need to set in order to get this software up and working. Those four are import, thickness, infill, and supports. First is the import. Take your file, open it in Cura, and make sure that your part sits within the boundaries of your printer. Basically, Cura shows a little box and make sure your part fits within that box. Second is your thickness. This is what sets how thick you want your layers to be. Think about it as your onion slices. The smaller the slices you have, the more detailed the print it's going to be. However, it's going to take much more time. The greater the thickness, the less time it's going to be, but it might not be as high detailed of a print. Third is the infill. The infill, as it sounds, is what fills up the entire model. You can have parts be near hollow by setting a low infill percentage, or parts be completely solid by setting 100% infill. Trade-off being here is time and amount of filament used. Lower the infill percentage, the more filament you're going to have at the end of the project. The higher, the more solid the part's going to be, but you're going to go through a lot of filament with a higher infill percentage. The final setting that you need to set is supports. And supports do exactly what they say. They support the tricky parts of the build. Imagine you have a portion of your part that's kind of sticking over the main body of the edge. As the printer prints up, you don't want anything else underneath it. You kind of want it just to overhang. What a support does is it's a tiny little structure that is built up with the model that's easily removed at the very end. This is all automated for you. In Cura, you'll start to see a little red portion on any portion of the model that Cura deems needs a support. All you do is check that box and let the software handle the rest. It's that easy. Now you're done. All you do is click all these boxes, click on the splice button, click export, and you're ready to go. The final step in the process is obviously the printing. Printing can vary pretty heavily based around what printer you're using, but should be fairly straightforward. For me, I use the Ender 3 V2 Pro. For this printer, I just have to manage a few steps. First, I plug in the SD card and turn on the printer. Pretty straightforward. After the SD card is loaded, I find the part that I'm looking to print on the model. And there's three kind of parameters that you want to keep in mind when you are printing on a 3D printer. The first one is the bed temperature, so essentially how hot is the surface that you're printing on. Second, the nozzle temperature, the little tip on the printer, how hot does that get? And the third is making sure your bed is level. And I can't emphasize, make sure your bed is level. My printer doesn't have an automatic function, so I have to do it by hand. When I print with PLA filament, the parameters I use is I keep a 200-degree nozzle temperature and a 60-degree bed temperature. For ABS plastic, I use a 240-degree nozzle and a 70-degree bed temperature. These were numbers that were built preset into my Ender, and I've never had issues with them. It's one of those things where with your filament, you might have a rating designated for it. Check whatever filament you have. Usually on the spool, they'll give you numbers or a range of temperatures to use and figure out what works best. As for my printer with bed leveling, I've kind of found a little trial and error process that works best for me. Essentially, I'll print the model once I think the bed is level and watch the first layer print. If the first layer starts to peel off a bit, I'll adjust as the layer is going until I think it is the proper thickness. Then I will turn off the printer, remove that first layer, and watch it print again and make sure I think those settings are correct. If your bed is not level, your part will not print properly, and I cannot emphasize this enough. When I was early on in my printing days, I did not level my bed, and I've had parts print for 14 hours and then fail, and there's nothing more devastating than seeing a giant part half broken when you wake up in the middle of the morning. Don't be me, level your bed, and take care of everything from there. Well, that concludes my video for today. I hope I was able to show you how easy 3D printing really is and how anybody can really use it. Highly recommend, if you can, get a 3D printer for yourself and try it out with all its benefits. As always, thank you so much for watching. If you have any questions, please don't hesitate to leave a comment below or shoot me an email directly. I'm happy to answer and help with anything. If you enjoyed this video, please consider subscribing, and thank you all so much for watching.